Hi, thank you for joining us here at SUSECon 2025. We're going to tell you how you can build a secure and resilient production environment for your AI applications. I'm Terry Smith, Global Partner Solutions Director here at SUSE, and I'm joined by two of our great partners. From DH2i, we have OJ Ngo, and from Microsoft, we have Amit Kandawal. The agenda for today is shown on the screen, and we begin with SUSE AI, the platform that's acting as the foundation for this solution. We will then move on to SQL Server 2025, whose new vector database capabilities are going to power our AI application. Now, to ensure enterprise resilience, we need DxEnterprise to provide the high availability and disaster recovery features. And finally, we'll bring it all together with a demonstration. SUSE AI is a fully integrated cloud-native platform for your AI workloads. We begin by recommending a solid foundation of SUSE Linux Micro. This is our immutable Linux operating system. On top of that, we recommend SUSE RKE2. This is our Kubernetes distribution that has a security focus. Running all of your applications will be SUSE Rancher Prime. SUSE Rancher Prime manages your workloads, your containers, and your Kubernetes distributions wherever they happen to be running, on premises, in the clouds, and even at the edge. Now, with SUSE AI, we also bundle SUSE Security to deliver full lifecycle container security to ensure that your applications continue to be secure. And SUSE Observability provides you with deep insights on how your entire environment and your workloads are behaving. Now, to ensure that you have the capabilities of building your applications in a trusted way, SUSE also is taking many of those libraries and models that you use already, and we are building those in our trusted build process on top of SUSE Linux Enterprise-based container images to ensure that those are also trusted applications that you can use to deliver your top-level AI applications. But one thing to note is that SUSE makes choice happen, and we ensure that you can use your own models, whether you use our secure versions, or you find your models from somewhere else, or you build your own. You have that flexibility in SUSE AI. Now, Amit, can you tell us a little bit about SQL Server and the new features that are available?
Absolutely. Thank you so much for giving us the overview of the SUSE Linux Enterprise Server and how the SUSE AI platform fits right into it. Now, with that, we are now going to talk about a vector store. And as you must have read, this vector store is SQL Server Linux that can be deployed as a package or as a container. So if you look at the right side of your screen, you'll notice that as the SQL Server package can be deployed as a systemd service running on SUSE Linux Enterprise, or if you are someone who prefers running containers on Kubernetes, without Kubernetes, even you can create custom container images which are based on SUSE Linux Enterprise or SUSE Linux Enterprise-based container images, like the SUSE AI that Terry was referring to earlier. Now, one thought that must be coming into your minds at this point of time, you've always heard SQL Server for almost 2+ decades, with SQL Server running on Windows, SQL Server being the enterprise-grade OLTP server which runs on Windows. Now, for the last 8 years, starting SQL 2017, we started supporting it on Linux. So you must be thinking, one thought that comes in, are the release cadences same? Is this the same SQL Server engine? Will I get all the database engine features that have been developed for the latest version like 2025? And the answer to all those questions is an absolute yes. So SQL Server on Linux is fully supported for production workloads. SQL Server on Linux has all the features of the database engine that you expect it to be there. In fact, the latest innovations that is happening on the vector side is fully available on SQL Server on Linux and containers. And if you want to download the SQL Server / packages, you could download it from the link that is shared here. Or if you want to create the container images, in a couple of slides, I'm going to show you how the Docker file is going to look like. With that said, let's talk about the latest release of SQL Server that's currently available as a private preview. And if you're someone who wants to go and immediately try the demo that we are going to show you, for that, you will need to sign up for this SQL Server 2025 private preview, because as of today, when we are recording this demo, the SQL Server 2025 is in a private preview, but it does have the AI capabilities that we are going to focus on, especially the vector store, generating embeddings, chunking the document. All of that innovations are available on SQL Server 2025. And as you can see, the idea is that you can choose your deployment option. So this could be completely on-prem, which is on ground, or it could be in cloud, or it could be in Fabric. You have the ability to develop at one of these environments and then deploy in multiple other environments. And that's exactly what we are giving you. And this is the same enterprise grade SQL Server that comes with variety of features, be it from T-SQL, tools, Copilot, AI, Fabric. All of those integrations happen right in the engine. And today we are going to very specifically focus on the AI aspect of it. Now, I really want to show you the demo, but before that, one quick thing that I want to talk about is how do you build your container images? So if you were thinking that it's going to be tough, the answer to that is no, it's pretty simple. And as you can see on the left is what we've built SQL Server on the base or latest base image. And on the right is the image where we use the base container image like the SUSE AI, which is built on. So you can use any of these based on your requirement and get started. And as you can see, it's very simple. We are just deploying the SQL Server package. And right now the deployment is from the local storage because this is in private preview, so you'll get the packages. So you have to do it the same way, but once it's available, it will be available on packages.microsoft.com, from where you can download and get started. With that said, all of this, we have an SUSE AI, we have SQL Server running. All of this is great, but for an enterprise application, one important aspect is high availability. And to bring that aspect into this demo, I have my colleague OJ, who will first help us understand how high availability comes in with DxEnterprise, and then we'll look at the demo. OJ, over to you.
Thanks, Ahmed, and hello, everyone. Thanks for joining us today. So DxEnterprise is a clustering stack. It provides core management, fault detection, and failover automation. It is really a simple clustering technology that easy to install, easy to manage. It can run on top of Windows or Linux, or in and out of containers. So one thing to note about the DxEnterprise is that it's built without pacemaker. In other words, it doesn't run on top of pacemaker or WSFC if you're on Windows. So with the DxEnterprise, you are allowed to mix and match your infrastructures, platform, distros. In other words, you can run a cluster that consists of physical machine, VM, or containers, and your node can be either Windows or Linux. So any node, anywhere. I think that's how we describe the DxEnterprise. And with the DxEnterprise, you can really stretch your cluster in and out of your environment. You can join between clouds. You can join between sites, and all of that is done over our private tunnels, discrete tunnel. And when talking about tunnels here, people say, well, what does that really entail? Well, it is a proprietary patented tech that allows you to stretch across the WAN without VPN or private data link or direct link. And because it's built explicitly for private and secure communication between your cluster members, essentially designed to boost performance of your communications. So in short, the DxEnterprise is a clustering tech that can run on any node, on any platform, anywhere. Okay, so with that, we want to take a closer look at how this join together, right? We have AI from SUSE, we have SQL Server that providing the vector stack, and we have the DxEnterprise providing the HA stack. And Amit, let's take a closer look at how we're going to build this solution.
Absolutely. So let's just put all of this together, because that's when the fun starts, and that's how you basically power your next gen AI and bring it to your database. So Terry, let's talk about SUSE AI, and then I'll talk about the databases.
SUSE AI gives you the same kind of flexibility you have with SUSE Rancher Prime to manage your workloads wherever they are running. But in addition, we provide those securely built AI libraries and models that you can leverage as part of your AI application. And again, the flexibility and choice is yours. You can use any model you would like to power your AI application.
Awesome. And the databases are also built on the familiar SLES environment, which is the SUSE Linux Enterprise environment. So I have a SQL on SUSE Linux Enterprise built container images that I've deployed. Remember, this is your very own enterprise grade OLTP database, which is also now acting as your vector store, which means it connects to your model, understands the data is converted into vectors, stored back into your databases, so that your application can then start running its hybrid searches, where you have full text and semantic search together, and your application can connect to the database, query it for vector search or semantic search. And the high availability stack, OJ, can you talk about that over here?
Absolutely. So for this particular solution that we put together here, collaborate on here is we will put SQL Server inside AKS, so Azure Kubernetes Service. So it in itself is a clustering technology, right? Kubernetes gives you pod level capability, failover capability. Now with the DxEnterprise, we are doing it at the database level to give it again performance and really the flexibility that you want and the high availability that you want. So let's dive into the demo a bit.
Absolutely. Over to the demo screen now. All right, so here's my notebook, which we are going to use the all new LangChain SQL Server, which has the capability and classes defined for the SQL Server to act as the vector store. And it also has classes defined where we are going to run the embedding, do the distance search between the vectors, so that we are able to do a semantic search, a true semantic search. And don't you worry, we've got you backed up, because all of this is provided and built on the samples that is available on GitHub. So when we share this notebook, you will have access to it as well. Now, before we start, what are some of the prerequisites? So the first thing, you'll need an Azure subscription. And please remember, for this demo, what I've done for the ease of access, because we have SQL Server built on SUSE Linux Enterprise, a container image which is built on SUSE Linux Enterprise. And this container image is deployed on Azure Kubernetes. And because we are running everything on Azure Kubernetes, we wanted to keep that in the same environment. So the models that we are choosing here is an Azure OpenAI endpoint with a ChatGPT model for chat completion, and then we have a text model for the embedding generations, right? So that's what we're doing. Now, you may ask me, what is the Docker file going to look like? Don't you worry, we already have you backed up, because in our files, we are also going to upload the Docker file for you that basically shows how the SQL Server / container image was built. So once you have all of these set, all of these prerequisites set, you are now ready to get started with the demo. And the data set that we are using here is a public data set available on Kaggle. And as you can see, I'm an avid reader of Harry Potter. So what I've done is, why not mix passion with job? So I'm just going to do all of this semantic data search on one of the text files that was available on the public data set. And I'm going to upload this one single file. So I'm not going to do all 7 books, just the one text file from one of those books. Now, before that, you need to deploy multiple packages, right? So what we have LangChain, we have NumPy, we have Azure Identity, so that I can connect to my blob storage. Remember, my data is on my blob storage, which is in the form of a text file. So I've got to load that into my SQL Server. So that is where I'm using Azure Identity. That is where I'm using Azure Storage Blob and all of those. So deploy all of these packages. You'll need them. Trust me when I say this. Once this is done, what you have next, you basically log in into your environment. I'm not going to show you what my subscription ID is. That's a secret. And then we have this very simple function. So as you can see in this function, what am I actually doing? I'm actually connecting to my blob storage, which has this text file, the Harry Potter text file that we was talking about. It has that text file, and I'm going to divide that one single text file, or split that one single text file into multiple documents, so that each document can then become a file that is uploaded inside my SQL Server. So to do that, the the lingo that is used in the AI world, I'm basically performing the chunking of the documentation. And this is the step that I'm doing now. I am praying to the demigods it finishes soon, because it does. And here you go. So it has finished in about 2.8 seconds, where that one single document was broken into 572 documents. Now, we've got to define the function that is going to, which is the chat completion function. In this case is the Azure Chat OpenAI, and LLM is that function. And to generate embeddings, the function name is embeddings. So I'm going to create these two functions. And again, please remember, this is using Azure AI services or the Azure AI endpoint in the backend. Now, once this is done, once the functions are created, what's next? The next step is where we initialize our vector store. This is my connection string, which is connecting to a SQL Server container that is running on Azure Kubernetes Service. And this SQL Server container is built on a SQL on SLES image, right? So that's the container image that I'm actually using. So if you want to see the Docker file of this container image, it's pretty much what you see here. As you can see, this is the SLES BCI that I'm actually using as the base registry or base image. And on top of that, I'm deploying the private preview bits, which is CTP 1.2 as of today, as of this recording. I'm deploying this and then starting the SQL Server and using the MS SQL user that is associated with SQL Server. So with that said and done, this is the SQL Server container running on Azure Kubernetes. And now what am I doing? I'm actually using the class that was defined in the LangChain, the SQL Server vector store. I'm saying that my vector store is this SQL Server, the connection string that is defined here. The distance strategy that I have is the cosine distance strategy. So the how similar are the two words to each other. That is defined by the cosine distance between those two vectors. And of course, if I have to compare two words, I need to generate the embedding, and the embedding is generated using the embedding function, which I just created. This is the embedding length that we support, and the table name is being called as the HP book 1. Yeah, I'm not that great naming tables, you see. So I just named it straightforward HP book _1. Good, I'm not a DBA somewhere right now. So with that said, when you actually look, I've also commented a couple of lines of code here. What I'm doing here is, after my vector store has been initialized, the documents that I had chunked, or the documents that now I have, I'm going to add those into my vector store, which has been, which has been initialized over here. And I've already done that. The reason for doing this is because I didn't want you to wait 7 minutes looking at a screen when this command is running. So I went ahead, took the liberty, and I've actually performed that operation already. Right now, I'm just initializing the vector store so that the function is loaded. And if you don't trust me, let me request you to trust me again, because here I am connected to the SQL Server. As you can see, this is the SQL Server instance that I'm connected to, and this is running on a container, and this is running on Azure Kubernetes Service, and this is running on SLES. If you don't believe me, I can actually show this to you with a very simple command, which is select at version. And when I do this, you will notice that I'm running on, let me just run this again. There you go. So you will notice that this is a SLES 15 SP6. So, and what does my table contain? As you can see, there is a primary ID associated with each document. I have 572 such documents. I'm just showing you the top 10 or top 9, top 10 actually. And as you can see here, I have, this is the content and equivalent embedding that you see over here. So this is the embedding for this content that has been generated, and this is my vector store, as you can see. Now let's go back to our Visual Studio Code, and as you can see, the vector store has been initialized. So now let's have some fun. So what I'm going to do is I'm going to perform a similarity search where my query is, I want to identify what are the different food items that was discussed in this wizarding world, right? So I want to see what were some of the food items that Harry and the team talked about. And what is happening when I run this query? It takes this query, goes to the model, gets the vector, goes to the database, performs a distance search, and then helps me bring all the data that it thinks is the closest to it. And as you can see, we are talking about toasts, we are talking about baked beans, strawberry, curry, grass. Oh my God, I'm getting hungry here. So I'm going to continue further. So you can see that there are multiple results. And if you want to see all the results, you can go to the text editor and actually scroll down. But I want to focus on the retrievable augmented generation pattern that we were talking about in our slide deck, right? So what am I going to do here? I'm actually going to create or define a system prompt where I'm actually trying to create a chatbot kind of an assistant. Remember the last slide that we showed, where we have this chatbot, where you ask question about your data, and it basically looks at that database, identifies what are the relevant answers for your question, and then presents it to you on your application. That's exactly what I'm doing here. So I'm saying this is an question answering chatbot with retrieved context, and you basically go back, search for it, and give me a context in 1 or 2 sentences. I don't want paragraphs to kind of read through it. So once I define this, and now I query, for example, I want to understand how did Harry feel when he first learned that he's a wizard and he's got magical powers. I would feel wonderful. So let's see, how did Harry feel about it? And as you can see here, right now, this is going in the backend, fetching the data from all the documents that it has, understanding what will be the best documents that can answer this. Based on that, generates an answer, and then writes it here. And as you can see, it's actually a quite human readable form where it is saying what Harry felt. It was disbelief. He thought it was probably a horrible mistake, despite different assurances that his team was giving him. And he had that experience, he had some of the negative experiences when he was growing up. So all of that is kind of well understood and presented here. Now let's take it a little more, let's add a little more fiction into it. So let's say the 3 of us who presented this session today. So I want to add 3 of us into this Harry Potter world. And to do that, what I'm saying is I wanted to generate a fan fiction story that I can tell to my daughter at her bedtime, that how I met Harry and I can act cool. So to do this, what I'm actually doing here is I'm giving a user prompt where I'm saying, write a short story about how Harry meets three boys, Terry, OJ, and Amit, on the Hogwarts Express and on the first day, and how they tell Harry about the native vector support for SQL Server 2025 that's introduced as preview with SUSE AI as the foundation and high availability that is being provided by DxEnterprise. And when I do this, it actually goes back again to the model, look at the different documents, understand the context, based on that, get the data, and then generate a fictional story that you can hopefully read it for your children and showcase how cool you are. So that's exactly what it's going to do. It takes about 30-40 seconds. Oh, great. It's completed in about 21 seconds. And as you can see, it's generated a fantastic story introducing three of us into the Hogwarts Express. And it's basically talking about us telling or sharing Harry the different things about the native Linux support for vector support, and how all of this is built on the SUSE AI foundations with high availability. Now, so far, I've been talking about a lot about how the story is built. Now, let's see high availability in action here. So what am I showing you here? I'm actually going to do a failover. So a primary pod, which is currently being queried by the application, the pod goes down because it's the real world. It's not the magic world, right? In the real world, bad things happen, and you can have a situation where your database pod goes down, and when it goes down, you don't want your application to actually immediately fail and things break. If you have a retry logic added to your application, that's exactly what we are going to show here. So what we are doing here, we are finding the primary replica, which is running my queries, and then we are deleting that particular or dropping that particular replica. And after dropping it, we are still continuing to query to see if there is an error. It throws an exception but continues to retry after 2 seconds and see if as soon as another one becomes primary, does it retain that data that was loaded into it, and does it still give us the answers that we are looking from the application side. So let's see this in action. So to do this, I am going to run this. As soon as I run this code block, you will see it first identifies the primary. In this case, the primary is this container, the DxMSSQL0. After it identified the primary, it killed it. Now this has been killed, and that's why the query didn't work. Now the fan fiction story is being generated because the second one has become the primary. Look at the first primary. It is in disconnected state. And in the backend, it's the DxEnterprise, the DH2i's DxEnterprise providing high availability. Less than 2 seconds, folks. It was failed over. Another primary was made. And once the primary was made, the fan fiction story got generated. You see the output. And once the secondary came back, after the pod was deleted, the Kubernetes brought the pod up. The high availability stack ensured that the new primary was chosen, and everything is back to normal. Isn't this magic? So I love bringing magic to the real world, and that's exactly what you're seeing here. And if you want to try this demo, as I mentioned earlier, it's available on on the GitHub samples, so you can go try it today. Thank you so much.